Hi, everyone. Happy Wednesday, and thanks for joining us for another virtual Lunch and Learn. I'm Jim Whitney with Marketing Technologies. Today's webinar will be short and valuable with another of our expert suppliers. Here at Marketing Technologies, we are a team of manufacturing and sourcing experts serving companies in the Western United States. We've been around for over 40 years, thanks to our world-class suppliers and OEMs like yourselves, who value the design and manufacturing support that we provide. Today, we're focusing on a specialized molding technology that offers an ideal balance of cosmetics and functionality for plastic enclosures. Now I'll hand it over to my colleague, Rich Baraki, Marketing Tech's manufacturing expert located a state over in Utah. Let us in on the agenda, Rich.
Thanks, Jim. In today's webinar, we're going to cover what RIM is, walk through a plastics process comparison, cover an overview of RIM's cosmetic feature that really sets RIM apart, a few case studies and key takeaways, and then we'll announce our gift card winners and wrap up with a few minutes for Q&A. I'm going to hand this over to Joel Blake, who's Marketing Tech's manufacturing expert, covering Colorado, California, and Arizona.
Hey, thanks, Rich, and a warm welcome to all of our webinar attendees. So who is Design Octaves? Since 1979, Design Octaves has specialized in full-service reaction injection molding to produce highly cosmetic plastic enclosures. Design Octaves is located in Northern California, a town called Soquel, just outside of Santa Cruz. They have about 50 employees and an ISO 9001 certified quality system. Primary industries served include medical, life sciences or biotech, and industrial. And one of Design Octaves' biggest advantages is their single source control of the entire RIM manufacturing process. So tooling, molding, finishing prep, paint, shielding application, and even light assembly happens all under one roof. Today we have the privilege of hosting Design Octaves President, Dan McCabe. Dan's had a long, productive manufacturing career. Spent his first 13 years at Hewlett-Packard, primarily focused in R&D and new product development. During that time, Dan also completed California State apprenticeship programs as a machinist and then as a model maker and tool maker. After HP, Dan moved over to Design Octaves, where he's been for the last 27 years. He started out as a pattern maker and CNC machinist, worked his way up to tool shop manager, then operations manager, and finally president of Design Octaves for the last 11 years. Dan, thanks so much for being here with us today. We're excited for you to tell us more about the RIM process and how we can use it to create beautiful plastic parts.
Hi, good morning, everyone. Thanks for joining us to talk about RIM today. We're going to be talking about RIM with kind of an emphasis on cosmetic finishing. And but first, we'll give you kind of a little overview of what RIM is. RIM is a low temperature, low pressure process that we can use. It's a two-part, A side, B side material with a low pressure, low temperature requirement. So we have a lot less issues with high pressure and high temperature required for injection molding. So the material it's a two-part liquid, isocyanate and a polyol. And you can see the image here where you have a work tank, A side, B side. Those two materials are mixed in the mix head at a very high pressure, but then dispensed into the mold at very low pressure. And the material is polyurethane. It's a rigid material. It's self-skinning, rigid with a microcellular foam. So if you were to look at a cross-section of the part, you'd have a solid skin on either side of the material with a microcellular core. Ideal for large parts because you end up with a fairly lightweight part compared to a lot of other materials. We kind of have we'll have a little illustration here of a cup shot dispensing the material. So it comes out of that mix head at a very low pressure, about like a garden hose, about 25 PSI. And in about 13 seconds, that material will start to expand. And we're using that reaction to fill the cavity of the tool. And also there's an exothermic reaction there that keeps the tool warm while we're processing. So we don't have to have any heating and cooling lines like you would with injection molding, and the material expands, and we use that expansion to fill the tool. So kind of give you a process comparison of where rim plays with injection molding, thermoforming, and cast urethane. So rim tooling can be, quite a bit less than injection molding, and ideal for low volumes. We're in that, 100 to 5,000 a year, where injection molding is suitable for higher volumes. On part cost, we're going to be more expensive than injection molding, and we can be less than thermoforming. If it's a complex part with a lot of details on the inside, we don't have to glue anything on. We don't have to do any post machining or anything. The parts are all molded, so you can actually save costs with rim compared to thermoforming. And cast urethane is really kind of an expensive part, prototype process for very low volumes. All our parts get painted, so you have a wide range of cosmetic finishes that you can get. Our parts are the rim process parts are very dimensionally stable and very rigid materials, so holding shape and keeping everything straight is easy with rim. And lead time is going to be better than injection molding and some other processes as well. So benefits of rim. So probably one of the big benefits is that you can have a thick and thin wall in the same part. So you can have a wall as thin as 3 millimeters, and you can have a wall next to it that's up to 15 millimeters, maybe even 20 millimeters in isolated areas. And you don't have to worry about sink and shrink like you would with injection molding. And then molding in, you can see in that kind of blue image on the upper left there, that has a molded in shaft. It has molded in standoffs. We mold in threaded inserts. I'll mold all of them in. We don't press them in afterwards. And we mold in magnets, and a lot of overmolding is possible. You ended up with a very rigid, lightweight part, and we can do large parts up to 65 inches, and depending on what the other dimensions are, but we can do big parts. And EMI RFI shielding, we have a UL approved process for applying EMI shielding as well. And really, this process is ideal for volumes starting around 100 pieces a year. Any less than that, if you're at 10 or 15, you want to go cast urethane, and if you're in the tens of thousands, you want to go injection molding. And then since we're kind of focusing on cosmetic features today, so everything we do is painted, as I mentioned before, and we're using mostly Sherwin-Williams or Cardinal catalyzed urethane paints. And these paints are very durable, scratch resistant, chemical resistant. A lot of our customers are in the medical and lab device industries, and those machines have to be cleaned with IPA or a Clorox solution or other types of cleaners. And we have customers that do that every day and don't have any problems with the paint. Very durable. You can get your part color any color you want. Everything is custom match. Surface finishes, you can have textured or smooth. You can have a matte finish or a glossy finish, and you can either have solid colors or metallic options. And we do a lot of multicolor paint jobs as well. So here's an example of a two-tone painted part with silk screening, two-color silk screening on it, textured finish, kind of a matte textured finish. And that's the inks we use on the silk screening they're a catalyzed epoxy ink that really bite into the paint finish. So you would have to sand that logo to get it off. You can't wipe that off, and it's very, very durable. We can also paint high gloss finishes. This particular client wanted a very glossy automotive style finish, and we can do that. This is a much more expensive way to go. It can double your part cost compared to a textured finish, because when you're painting these, it's pretty much like painting a car. You have to go through and double prime, do extra body work, lay down the base coat, wet sand the base coat, apply the clear coat, and then go back and buff the clear coat if you need it. So, it depends. If you need this, that's great, but it's not as economical process as going with a textured finish. And the way this is done, this client really wanted to have that orange stripe in that right side to really look clean and crisp. So what we did, we worked with them when they were doing their part design, and make sure we put a nice little recessed area for that orange stripe. It's recessed about 20 thousandths, so that when we lay the tape in there, we can get a really nice clean line. So you can see that line that's a hand mask line, but it comes out perfect. Clear coat goes over it and comes out really nice. Some clients want kind of unusual paint jobs. This client wanted a purple part that faded to blue, that faded to light blue. So we can do that. It looks pretty good. It's kind of tricky to get that to come out. It's more of a art project than an industrial paint job, but we do this in production quantities, and clients very happy with this. And then again, that's silk screen on the front, and that looks really nice with the white, and it pops real nice. Looks good. And then talking a little bit about EMI RFI shielding. This is a sprayed-on material. We maintain a UL cert for adhesion to our substrates, and we just have zero issues with adhesion. Probably 70% of the parts we do get some type of EMI RFI shielding. In this case, the client wanted everything exposed on the inside of the part. You can do that, or you can mask off tops of bosses or edges of parts where the sheet metal or a casting is going to make contact to get your continuity, and then have overspray permissible. We'll talk to you, as your project's developing, and find the most cost-effective way to do your masking and shielding. So, case study. This is a medical cart. You can see on the left, that's their old version, and the new redesigned version is on the right. It's a patient temperature management device, a cart, and we do quite a few different medical carts. The challenge here was these were large parts, critical fit. They wanted those curvy parts to fit together and have real nice, clean, consistent reveals, and high-end cosmetics. We've got a matte finish metallic on the front of that part, and then there's a cast aluminum handle that also you can see that the handle gets painted to match a silver area on the rim side panel. So this particular client wants that match to look perfect, and we were able to pull that off. There's 5 different rim parts. I mentioned the aluminum handle, and then there's multicolor silk screening up at the top. Here's just another shot of that cart, and showing you some of the details on the back panel, side panels, and this came out really nice. The fit is perfect. The finish, the match between the aluminum handle and the rim part comes out looking really good. So here's another case study of a life science device. It's a genome mapping device, and this is one of the nicer looking units that we build. It looks good. It's a big enclosure. It's probably about 32 inches wide in the front there, and this is a 3-piece enclosure. They want very tight reveal lines, and they want the cosmetics on that front panel to just be perfect. So we worked with them. We did quite a bit of DFM work on the tool design to make sure that everything was going to fill properly, look good, and also once you paint it and silk screen it, it's going to look right. On this particular client, they had 2 different kind of areas where they needed two-tone, and we had 2 different treatments. So in the image on the left, on the lower right, we went with a very small ball groove in the part so that we can mask that. We spray that dark gray area first, and then we can tuck the masking tape down in the bottom of that little, it's about a 60 thousandths wide ball groove, and it looks really clean. In that image on the right, it was a little deep in the tooling to get a small ball groove where we're down in that corner. So we went with just a sharp radius. We've got about a 30 thousandths fillet radius in there that we mask right up to, and it comes out looking really nice when it's all done. But we work with you on, what type of features you need to end up with a really clean cosmetic finish. This is a life science machine. It's a single cell analysis lab system. Really good looking unit. This is probably about 30 inches tall. It's a desktop lab device, but it's a pretty good sized part. Again, very challenging geometry and fit with all these curvy, swoopy parts and having them come together and look really nice. Very high-end cosmetic requirements on this. The front panel on this actually tilts back and forth, that black and blue part, and the client wanted that to be a glossy finish. So you have to do the same thing, the double prime paint, sand, color sand, clear coat buff, and same with the blue trim around the front of that. And then the rest of the part is a standard textured finish. And the combination of the texture next to the glossy came out looking really nice. And we've got, ball grooves where we need it, where they make sense in the tooling, and then we have steps to mask to in other places. There were 6 different rim parts here with a combination of finishes, and it came out very nice. So this is a medical device. This is a cancer therapy machine, and this client came to us with an interesting question. Is they said, can we mold the part and hold the weight, a consistent part weight from part to part? And we're doing metered fills, and we can hold very close tolerances on part weights. The process they were currently using was fiberglass, and the parts would vary from part to part. You could have one part that weighed 5 pounds, one that weighed 3.5, and one that weighed 7. And it made calibrating the arm, that part is mounted on a movable arm. It made you had to go recalibrate the machine every time if you changed out a panel because it had a scratch on it or something. So you had to recalibrate. With our parts, consistent weight, they could change out parts. They don't have to send a tech out to recalibrate, and it worked out really well for them. They also wanted this very thin kind of laser cut sheet metal insert, the vent insert, and that worked out great. They were trying to paint it at another shop and then bring the two together and have a match, and there was a lot of issues with getting part match. So we also source and paint that aluminum sheet metal to match that part, and they get a perfect match. That panel has little studs on the back of it, and then we mount that with nuts on the back side. And again, it's very thin, 40 thousandths aluminum, because weight was an issue on this part, but it worked out really good. So we can paint other process parts to match. If you need to, machine parts or other plastic parts or sheet metal parts, we paint injection molded. If you have a little door or something that goes with the rim part and you want to have a real perfect color match, we can do that. And why would you choose rim for cosmetic enclosures? And well, you have a lot of design freedom. You can do complex geometries. You can have thick and thin walls and mold it in features and inserts. And the rim benefits. It's a lightweight, durable, rigid material. You can do EMI, RFI shielding, and large parts and small quantities. We really specialize in low quantities. Our lot sizes are anywhere from 10 to 25 to maybe 50 to 100 parts at a time. So if you're building 500 units a year and you have a bunch of big enclosures, you don't want to have to get all 500 of them in one shot. And so our process is set up to run in low volume. So if you want 50 a month or 25 a month or 100 a quarter, or however you want to manage them, we can match your build quantity, and it's very economical to do that. On the cosmetic finishes, there's lots of multicolor options, lots of textures and glosses available, and really tight controls. We're painting them all in-house here, so very tight controls on paint, on color, gloss, and we have a light box, we have a gloss meter, a spectrophotometer. So every new batch of paint comes in, it's inspected very thoroughly, and we have a very critical eye, as our clients do as well. And we never have any issues with color match, texture match, gloss match. We have really tight controls on our paint. So from a cosmetic finishing point, you don't have to have, you have nothing to worry about if we're painting your parts for you. Okay, I'm gonna hand that back to I think it is Joel is going to be.
That is Jim Whitney. So thank you very much.
Sorry.
I really appreciate that, and thank everybody for for joining us today. Next, we'll have a quick drawing for our 3 gift card winners. And then we'll finish up with our question and answer session. You should hang around for that. You can chat your questions over to the chat window on the right-hand side of your screen, and we'll be happy to take some time and get your questions answered. Another couple of quick reminders, or one last reminder, I should say. If you want a customized presentation, we can either do that virtually or come visit your facility, understand your specific designs, and put together a presentation, DFM product, and see if it's a good fit for the RIM process at Design Octaves. With that, we'll announce the 3 winners of our gift cards, which you can restaurant or request a donation to your local food bank. Those 3 winners are Troy D., Pierre M., and Mark B. And with that, I'm going to hand it to Joel for the Q&A.
Thanks, Jim, and thanks, Dan. That was a really great overview. And yeah, we've had a lot of customers take us up on our on-site seminar offer, and they are super educational. We bring a lot of nice parts for you to touch and feel and kind of compare to what you're designing. So yeah, as Jim mentioned, our attendees have been chatting and emailing questions for Dan throughout the webinar. So Dan, our first question from the audience is, what are your typical lead times with REM? And they kind of broke the question down into typical lead time for repeat orders, setting up a new design, and how are you also managing some of the challenges of material availability and lead times in the current market, which we all know has been a little chaotic.
Sure. Yeah. So typical lead times for tooling, if you're doing, one single tool or maybe 2 smaller, simpler tools, you're in the 6 to 8 week range time. And then if you're doing large multi-tool projects, you could be in the 10 weeks plus, depending on complexity of geometry and size of parts. Repeat orders, production orders, typically we're in that 6 to 8 week lead time range for repeat orders. And we work with a lot of clients to do, blanket orders with planned releases, so we can do that as well. Let's see, material availability. Yeah, we were a little worried, back in January, February with polyurethane coming from Dow and their plants in Texas. And we're very lucky. We keep extra material on hand all the time anyway, to preclude any shortages. And we never had any shortages. We were under a force majeure with Dow for many months, and we never had any shortage. We never even really got close to running out. So we've been really lucky in that realm. And also with our paint, we haven't any issue getting paint, but we're a low volume. We're not using millions of pounds of material or thousands of gallons of paint or anything. So a lot of our suppliers were able to take care of us just like normal. So we've been pretty lucky. Yeah.
Yeah, that's great. It's certainly seemed to have dodged a bullet there. Some of our injection molding customers really got shaken up by the materials market, and it's nice that you guys use the same material for different types of applications, and you can kind of keep some of that on hand. Another question that has come in. So you referenced DFM support on one of the case studies, I believe, Dan. So this person wants to know, how involved does Design Octaves get in DFM, and when at what point in the process do you get involved, or do you like to get involved?
Well, we get involved a lot. We like to get involved early, and we do as basic as just giving you a quick review and giving you a few screenshots of what you might, any really gotchas that, thin walls or draft issues or that type of thing. And then we've gone as extensively as having our tool engineer do file development for the client. We've done that on a few different cases, and it's worked out really well. That is having him, Tom Falcon, as our tool engineer, to have him do that. It's kind of schedule driven. If that works, that he's got free time, so it's kind of hit and miss on that. But at a very minimum, we always do a very thorough DFM review with you to make sure that there's no areas that are going to cause issues with the part strength or warpage, or a lot of times we'll recommend additional ribbing or thickening up a feature, or adding a threaded insert attachment point, that type of thing. So earlier is better. We can give you a real good idea of where you are and how far you are from it being a rim part, early on. So yeah, earlier is better.
Okay, fantastic. So next question that came in is around some different aspects of rim tooling. So they want to know what material do you use for your tooling? How many cycles can a user expect out of a tool? And then also typical costs that you run into for tooling setup and maintenance.
Sure. So yeah, our tools they're a cast epoxy aluminum tool. So what we do to build our tools, we CNC machine a very accurate master pattern, and then we cast our tool around that master pattern. That does you a couple things. It lets you see those patterns kind of as an intermediate checkpoint, do a dimensional check, and make sure the pattern is all correct before you ever cast the tool. We have been building cast epoxy aluminum tools for over 40 years and have just had great success with them. We guarantee every tool for a minimum of 10,000 cycles, and we've had several tools that went in excess of 20,000 cycles. So, for our low volume clients, it's really, life of the project, and the tools really last. One nice thing with these tools is there's never any setup fees. If you order 10 parts, or you order 50 parts, or you order 500 parts, there's no setup fees because our tooling is designed for very rapid setup. We can have a tool off the shelf and be running parts in less than an hour, and we've designed our tools and our process that way to run low volume. So that works very well. The customer owns the tool, but you will never get charged any kind of maintenance fee or cleaning fee or anything like that. That's we keep that tool in good order for the life of the project, and never charge any setup or maintenance or cleaning fees.
Okay, great information there. So I'm going to take a creative liberty and combine a couple of questions that have come in here. So one slide we talked about, max dimension of 65 inches in rim. I know that's probably dependent on the other dimensions of the part and things. This question is more the other end of the spectrum. When do you think a part is too small for rim, or is there a certain point where small parts become less cost effective in rim? And then sort of combined with that, just a general question is, are you aware of any sort of decision trees or flow charts that would guide customers on how and when to use rim versus other plastic processes?
Yeah, that's a good question. So, yeah, it really, on smaller parts, we have clients that if you've got a part that's the size of an iPhone, we mold them sometimes, but not very often. And what I would recommend is go get that injection molded. And then if you need to get it painted to match your rim part, we can do that. But we still have clients that we just want you to do it. So a lot of times we can either do a family tool and hang a couple of small parts with a larger part, if the geometries are line up well enough. So it's kind of, anything. I kind of sometimes say keyboard size and up makes total sense for rim, but then we do a fair amount of parts that are smaller. So, we'll definitely tell you, if you bring us a part that's suitable for another process, we will tell you right away. We don't want to try to make rim fit for every part out there, because it doesn't. There's parts that you send it to us for quote, and it's definitely an injection molded part, either on volume or on small size or shape of the part. And sometimes, there's other processes that it would be better. Your volume's too low. Maybe you should use cast urethane. If there's very little detail on the inside, maybe thermoforming would be a better choice. So I always encourage customers where a part's kind of in between processes, get quotes in both processes, and then kind of make your decision based on where it fits best. I'm not really aware of any like a flow chart that would take you through how to do that. I would just say if there's a question about which one you want to use, then you have them quoted in both, and make your decision based on that.
Yeah, that's really good context, and I'll add too that our team at Marketing Tech, we put together a low volume plastics comparison presentation a while back that's a lot of customers have found useful. We work with multiple processes like rim, structural foam, thermoforming, so we kind of have some comparisons of projects that have been quoted in multiple, and we can give you some idea of case studies there that might be helpful. We're emphasizing cosmetic kind of outer enclosures here today, Dan, but one customer was just curious if there's internal, more structural parts. Would rim be a good fit for that, in addition, or do you kind of steer customers away from using rim for structural bracketry and things on the inside of a product?
Well, we tend to call our parts their cosmetic exterior panels, but we do have clients that sometimes use it for structural parts, and part of that is because you can go thick walls and have a structural part. Usually those clients are the ones that want to do one-stop shopping and don't want to source a bunch of different parts at a bunch of different suppliers. So yeah, technically, I would say we're not really structural. You're not going to want to make a chair out of this or something that's going to get beat around in the back of a pickup truck. But we're mostly cosmetic panels. But then there are ways to, if you want to thicken up a wall and make it more structural around a latch or around a hinge area, or for cosmetics to make it look better, we can do that. But yeah, pretty much we're cosmetic panels.
Perfect. And one other question that's come in is just thinking about temperature exposure to rim parts. So have you run into any products that are, might be stored in a warehouse in Texas in the summer, or a super cold environment in the winter, that you've had issues with the rim parts distorting or struggling with those temperature swings?
Well, we do. We're good up to about 170 F on a little higher than that on both of our our rim dowel systems, and then we have another one, a 3 millimeter system that's kind of good for a little bit higher temperatures. If you have a really high temperature application, then the rim's not. If you're going to be exceeding 180 degrees F on a consistent basis, then that's probably not a good solution. But as far as storage tempers and that, we have storage temperatures. We have materials available that can withstand. A lot of our customers have specs on that. Their warehouse storage temp has to be 150 degrees F. Has to be able to withstand that without distortion. And then we're also very aware of how to package parts and box them so that you're not going to cause any kind of distortion just from the way you're packing and storing the parts. So yeah, we have options available that we ship parts all over the world. We ship all over Asia and Europe and all over the United States, and hot climates and cold climates, and we just don't really have any issues with that.
Okay, perfect. And looks like this is going to be our last question, then we'll let everybody go. Handles on mobile carts. So we saw a couple examples of a molded in metal piece inside a rim handle, and then I think we saw a casting on one cart as well as the handle. Do you typically guide customers if they want to use rim to mold a tray or a handle on a cart that's going to require some strength? You're going to be pulling around the unit. How do you guide customers in terms of achieving the strength that they need with rim? Do you typically recommend an insert for strength, or what do you see most commonly?
Well, it kind of part of if it's going to be, you can make a rim handle on a cart. We have a couple where we do that. You kind of have a thickness limitation there. If you can go up to about 15 millimeters thick in a wall section. So if your handle could be 15 millimeters or less, you're probably okay. But a lot of times the client wants a thicker feel. They want to have like a 1 inch thick section or a 1 inch round. And in that case, I'd either say, well, get a cast aluminum handle, or we've had clients that you can overmold. You can overmold a tube. You can overmold some different things to give you that size and shape. So it's kind of thickness driven. If you want it as part of as an integral part of the rim part, we do a couple of different carts like that where they didn't want to have anything else bolted on. They wanted it to look all like one piece and painted like one piece. So we can do that in rim as long as it's not too thick, or it can be cored out from the bottom. Sometimes the client, if it's cored out from the bottom, they don't like the feel of that when you reach your hand around there and then you feel that core on the bottom. So it kind of depends on thickness, and but there's 3 different really good normal standard options to get handles on carts. You can either do it all rim, you can do it over molded rim over a sheet metal or a tube, and then you can do like a cast aluminum handle like the one we saw earlier in the presentation.
Awesome. That's great information. And yeah, just a reminder to everybody that we love to consult with our customers on early design, development, DFM, prototyping, all that stuff. So reach out as soon as you have your design kind of at the concept stage, and we can start helping you with some of these particulars. So that's our last question. Dan, I just wanted to express our deepest appreciation to you again for the time, and this was an action-packed half hour. So I hope that everyone got something out of it, and we'll follow up with a recording of the webinar and some supplemental materials that hopefully will, little by little, will help this knowledge stick with you over time, because RIM is a very interesting process that a lot of our customers have had good success with on high cosmetic plastic enclosures. So thank you again, Dan. Thanks to the whole team and all of our webinar attendees, and everyone enjoy the rest of your week.